Hey guys, today's lesson is on graphing piecewise functions. Piecewise functions are similar to just graphing regular linear equations. However, instead of graphing the whole line, piecewise functions, we're only going to see a piece of the line. We're only going to graph a certain part of that line. So what I'm going to do is I'm going to do all the even problems in the video, and I'll leave the odd problems for you guys to try. I'll of course show you guys the answers. So here, number 2, this is in function notation, and this piecewise function, f of x equals 3, could also be written as y equals 3. That's another way to write it. Now, we don't want to graph the entire line y equals 3, which would be the horizontal line at the y-axis at specifically 3. Notice that this is in slope-intercept form. It has a slope of 0, therefore it'll be a horizontal line, and it will cross the y-axis at 3. We don't want to graph this entire line. We only want to graph a piece of this line, specifically the piece where the x values are less than 0. At this point, we want to look at our x-axis here to look at the x values of the function, and just graph the part of that line for the x values less than 0. What part of the x-axis has less than 0? It would be this left part of the x-axis. So which part of that line do I want to graph? I only want to graph this part of the line. Therefore, we will erase the part to the right where the x values are greater than 0. In addition, we did learn a couple sections ago with inequalities, if it's a less than sign, this solid circle is showing that x does equal 0, since it's a solid circle. Since they want the x values just less than 0, what we're going to do is use an open circle. So this is a piece of the line y equals 3 where the x values are less than 0, and that is the piece of the line that they want us to graph. Another option is to use a table to help you guys figure out what the line will look like. For example, if I wanted to graph y equals 3 for x values less than 0, I can make a little table and pick 0 and values less than it, like -1 and -2. I could plug the x values into the equation to find the y values. Since there are no x values here to plug into, what that means is every y value is going to be 3. I can now plot these ordered pairs and see what the piece of the line is that they want me to graph. Since the x values have to be less than 0, and I chose 0 there, when I plot 0, 3, it's going to be an open circle, and every point after that will be a closed circle. -1, 3, -2, 3, and if we continued, it'd be -4, 3, -5, 3, so on and so forth. So we would just get this piece of the line with an arrow towards the left. It's not the entire equation. It's not the entire graph of the line y equals 3. It's just a piece of it. Let's go ahead and move on to number 4. As you could see, there are 2 lines in the function in which we're going to get 2 pieces on our graph. We're going to do the first line of the function first, and then the second one second. F of x equals -x can be written as y equals -x. If I wanted to graph this line just out as it is, the y-intercept is 0, and the slope is -1. So I would go down 1 and right 1, and I would then graph my line. The only thing is, they don't want us to graph the entire line. They just want the piece of this line for the x values less than or equal to 0. What part of the x-axis has the x values less than or equal to 0? It would be the left side. Therefore, we'd go ahead and erase all the part of the line that would be on the right side of the x-axis or greater than 0. Since it is less than or equal to, we're going to use that solid circle showing that 0 is included as an x value. Again, another option to graph this is using a table. Let's say we would use a table, and what we want to use for the x values is the x rules. They say to choose the x values less than or equal to 0. So I'll choose 0, -1, and -2. I'll plug it into the equation. When I plug 0 in, I get y equals -0, which is 0. When I plug in -1, I get y equals -1, which is +1. And when I plug in -2, I get y equals -2, which gives us +2. Let's go ahead and plot these points. 0, 0 is our first ordered pair in the table. So that point is here, and we'll be graphing with a solid circle because the solutions are less than or equal to 0. Since it's a less than or equal to sign, be a solid dot. Let's plot the other points we found. The second one is -1, 1, which would be here. The last one is -2, 2, which is here. And if I were to continue on, again, I would get the same piece of the line as I did before, which looks like this. I don't want to graph the entire line, just the piece where the x values are less than or equal to 0. Let's go ahead and do the same for now the second piece. We're going to have two pieces on one line. So the second piece of the function can be written as f of x equals 2x minus 2, or y equals 2x minus 2. We could either A, graph this line and erase the part that the piece is less than 0, because now they just want x values greater than 0, or we could use a table. Let's go ahead and use our table real quick. They want us to pick x values greater than 0. I'm going to pick 0, 1, and 2. And since the values are greater than 0, when I go ahead and plot that point, it's going to be an open circle. So when I plug it in, 0, we'll get -2. When we plug in 1, 2 times 1 is 2, minus 2 is 0. And when I plug in 2, 2 times 2 is 4, minus 2 is 2. Let's go ahead and plot the ordered pairs. The first one is 0, -2. And remember, we're going to plot that with an open circle because technically the x value of 0 is not included here. 0, -2 would be this ordered pair there. The next ordered pair is 1, 0, which would be here. And the third ordered pair, 2, 2, would be this point here. As you could see, this is 1, 0. As you could see, we're going to continue getting points going up to the right, in which we will then finish that piece of the line, graphing it like so. Again, the entire equation, y equals 2x minus 2, would have a y-intercept of -2 and a slope of 2, so up 2 over 1, and it would be this entire line. But they don't want the entire line, they just want the piece where the x values are greater than 0. So we, of course, would just erase the bottom half and show that it would just finally be this piece of the line. And in the first problem, there was one piece. In the second problem, number 4, we have 2 pieces. And lastly, we'll look at a problem where there is 3 pieces. So here are 3 pieces of 3 different lines that we're going to graph on the same coordinate. The first piece is f of x equals -x. That could be written as y equals -x. We could either graph the whole thing and erase for x values less than or equal to -3, or we could use a table. Let's first graph the whole thing and erase, and then I'll show you guys how to use the table. You do not have to use both of these options, you just have to use one that you're most comfortable with. So y equals -x would have a y-intercept of 0 and a slope of -1. So the line would look like this. However, they don't want this entire line to be graphed. What they want is the piece of this line for the x values less than or equal to -3. On the x-axis, where is the numbers less than or equal to -3, it would only be this part of the x-axis. So they only want that part of the line. It's very, very small. So what would it look like? We would erase, and we would have this piece, just making it neater here. Left one, up on this piece of that line. That is option A, where you could graph the whole line and then erase for the piece that they want. Again, they just want from -3 and less, so that just piece on the coordinate plane. Another option, might be easier for some of you, is to just do a quick little table. They want us to use x values less than or equal to -3. So we'll pick -3, -4, and -5. -3 is +3, -4 is +4, -5 is +5. When I plot this, I'll show you that we're going to get the same piece as we already graphed. -3, 3 is this point here, and we're going to keep it a solid point because it's a less than or equal to sign. -4, 4, -5, 5. We'll continue graphing up to the left, and we will still get that same piece. All right, so two options, whichever one you feel best with, you could use. Let's go ahead and graph now this second piece, f of x equals 2. Now, this one is similar to like the first problem we did on this video, where that line can be written as, or the equation is y equals 2. This is a horizontal line where y equals 2, or the slope is 0 crossing the y-axis at 2. It is this line. However, they don't want us to graph that entire line. They want us to just graph the piece of the line that's in between the x values, -3 and 0. Where is -3 and 0 on the number line? This is -3, this is 0, so they want this part of that line. They just want a piece of it. So what I'm going to do is erase the right side, erase the left side, look to see open or closed circles. Since they're both just less than sign, they're both open circles, and that would be the piece that we want to graph. All right. If you wanted to use a table there, we could do x values from -3 to 0. That's what this is asking us to do. So we'd have to pick -3, -2, -1, and 0. There's nothing to plug into this equation because there's no x value. Y equals 2 means every y value is 2. So what ordered pairs would we plot? X is greater than 3, so I'm going to do an open circle at -3, 2, which is here. I'll use a different color, which is here. -2, 2, -1, 2, and 0, 2 has an open circle as well. And as you could see, we're plotting the same exact piece. If you want to graph and erase or use the table, that is up to you. Let me neaten this piece up just a little until we get to our next one. So this is the piece of the line from x is -3 to x is 0. Here is our last piece. The last line is f of x equals x. So let's take a look at what that's going to look like. I'm going to do the table first this time. We could rewrite that as y equals x, and they want us to graph that equation for x values greater than or equal to 0. So I'll pick 0, 1, and 2. When I plug 0 in for x, I got y equals 0. When I plug 1 in for x, y equals 1. When I plug 2 in for x, we get y equals 2. Let's go ahead and plot these points. Notice x is greater than or equal to 0, so when you plot this first point, we're going to use a solid dot, 0, 0. The next ordered pair is 1, 1. The next ordered pair is 2, 2. We would continue moving up to the right and graph our piece of that line. This is really as difficult as it gets, is when we get 3 pieces on the same graph. You guys could graph and erase if you wish, or you could just do a table for all of them, okay? The next page, we're going to be doing the opposite. Again, I'm going to just be doing the even problem. I'm going to show you the answers to all of them at the end so you guys could practice. So for number 2, what they want us to do on this second page is write the piecewise function. As you can see, we have 2 pieces here. So we're going to start writing f of x equals, with our brackets, we're going to have 1 piece at the top and 1 piece below it, okay? We're usually going to work from left to right. So we are going to take care of this piece first. The first thing you want to do is write the equation of that line. How am I going to write the equation? We're going to do it in slope-intercept form, which means I need the slope and the y-intercept. This is a horizontal line, so it has a slope of 0, and the y-intercept is also, the y-intercept is 1. I could see it crosses the y-axis at 1. The equation of this line would be y equals 0x plus 1, but we know we're not going to leave it as 0x, and we would rewrite it as y equals 1. How am I going to translate that now into my piecewise function? We already have f of x, and that's going to be used for both equations that we're going to write. So that is like our y equals part. So the first equation is just going to be 1 if, and now let's figure out what x values that line is covering. Now what I did was I split it into a green section and a blue section to show you guys that this piece that we're writing an equation for is in the green section. If you take a look at the x-axis, what x values are in that green section? 0 and all the numbers less than it. Since we have an open circle here, we're going to say if the x values are less than 0, since it's not included. Let's now take a look at the second piece, the one towards the right. Let's go ahead and write our slope-intercept form equation for it. I need to know the slope and I need to know the y-intercept. Well, the slope, you could either use rise over run, or you could take any 2 points of the line and find the slope. The points I would use would be these 2 points, 0, 2, and 2, 3. If I were to put 0, 2, and 2, 3 in a slope formula, it would be 3 minus 2 over 2 minus 0, which is 1 over 2. I found out that the slope is 1/2. If you did rise over run, you could see that you're going to rise 1 and run 2 to get your slope of 1/2 again. What is the b value? Well, we could see with our eyes that it crosses the y value, the y-intercept at 2. So the equation here would be y equals 1/2 x plus 2. Now, let's just copy it in our piecewise function. Again, the f of x part is used for both. That's like the y equals part. So now the second line is going to be 1/2 x plus 2 if, let's talk a bit about the x values that piece takes up. That section is the blue section. As you can see, the piece that we're talking about here, the second one, this piece, what x values does it cover? Let's look at the x-axis from here to here. In the blue section, those are the x values greater than or equal to 0. And I know it's greater than or equal to because it's a solid circle. So if x is greater than or equal to 0. What I'm going to ask you guys to do next is to practice the odd problems. And then you could head on to your ed site. I'm going to show you the answers for all the problems in a second in the video. If you have any questions, please let me know. Here are our answers for all the problems on the first page. Feel free to pause the video to double check all your answers. And here are answers for the second page. Again, go ahead and pause the video to see the answers.